Okay. Hello and good afternoon. Please, can you hear me?
Yes, sir, we can hear you.
Okay. So you're welcome to this morning's continuation of logical statement. So we are going to recap the rules, and then from the recap, then we take the last part of the statements that we call valid arguments. Okay, so briefly, let's go through the various connectives that we went through, and then from there, we'll look at a valid argument. Okay, so these are the summary of the connectives. These are the summary of the connectives that we saw last week. The first one is known as the negation. And the negation, we said, if the original statement is true, when you negate it, then it becomes false. If it is originally false, when you negate it, then it gives you true. So that's for negation. Then we came to the connective and. Now, and we said when the original statement, both of them are true. If you are joining two statements with P, Q and using and, then look at when both of them are true. If P is true and Q is true, then the connective P and Q will be true. So that's for the connective and or conjunction. Now, the connective or, which we call a disjunction, we said at least one of them must be true. At least means that one or more. So that's why the meaning is either P is true or Q is true or both of them are true. So that is for the connective or. Then we had the connective exclusive or. Now, exclusive or is a circle with a plus. Now, this connective, the way I define it is that exactly one must be true. So either P is true and Q is false, or Q is true and rather P is false. So it means that either P or Q, but not both. It means that the difference between this and the normal or, when it comes to both of them being true, exclusive or is rather false. Then I remember that we went to biconditional before we looked at the if and then. The biconditional connective, this one, it is an arrow on both sides of a line, P biconditional Q. The rule is if your truth value is the same as mine, so the word is if and only if. If I'm true, if and only if you are true. If I'm false, if and only if you are false. Then when we combine, our combination will be true. And then the last one is P if implying Q. Now this connective, like I said, is one of the connective that is very important and has so many names. Now, the names that it has were, one, you can have P implying Q called implication. You can have Q implying P called converse. You can have minus P implying minus Q called inverse. And then minus Q implying minus P called contrapositive. All this refers to the connective if and then, depending on what is on the left. If P is on the left, then it implies. If Q is on the left, then it's converse. If minus P is on the left, then it's the inverse. And it's minus Q on the left is called contrapositive. The same connective, you can use the word if P, then Q to mean P implying Q. You can also use if P, comma Q, still means P implying Q. And you can use the word sufficient, necessary, whenever. All this, including Q if P. If you have Q if P or Q when P, they all mean this P implying Q. Okay, so these are the various names for if and then. But the rule is, if P is true and Q is false, then, this one. If P is true and Q is false, then if P, then Q will be false. This is the only connective that we look for the truth value to be false when you connect using the implication sign. Okay, so all these questions or all these examples that we have, all these rules were the things we saw last week. Basically, that's how far we went. And we took a question on if the moon is made up of green cheese and on and on and on. Now, so last week we realized that these connectives or these logical statements, when they are joined together and draw the truth table, you can form a tautology, that is a statement that is always true, or you can form a contradiction, that is a statement that is always false, or you can form a contingency, that is a statement that is both true and false, combination of them. Okay. So those were the examples we saw last week. So this is where we are. What makes a statement to be valid, or what makes an argument to be valid? Okay, so let's go through the rules and then we will go to the Excel to be able to solve an example there. Now, an argument consists of a set of propositions. Now, these propositions, the beginning of those arguments are called premises. Okay? And then the ending of those statements are called conclusions. So when you are given an argument, your build-up of the argument, the beginning part is known as premises, and then the ending part is called conclusion. Now, what you are supposed to do is that you identify all the premises. If there are two premises, then you call them P1, P subscript 1, P subscript 2. If there are three premises, we call them P1, P2, P3. If there are four, you call them P1, P2, P3, P4, on and on and on and on. And then the last one is always your conclusion. Now, what do? You would take all the premises P1, join it to P2, join it to P3, up to the last premise, and find out where are they all together true. That's why in the slide I'm saying P1 and P2 and P3 up to Pn. Where are they all together true? When you find that place, go and compare those particular rows with the conclusion. If those rows are also true, then the statement is valid. Okay, so that's what he's saying, that an argument is valid whenever each of the premises P1, P2, P3 up to the last premises is true, and the conclusion C is likewise also true, then the statement is valid. Okay, so that is a theory. How do we actually identify these things in the problem? So we are going to take two examples in the slide, and then we'll take more in the Excel. Okay, so I'm just repeating myself that an argument is made up of statements. So a statement is identified by the beginning of a sentence. You see a full stop or a semicolon. Okay, so you count all the statements that are beginning, they become your premises. And then normally your last statement is always your conclusion. So let's try this. Can we try this question? Now, if it is raining or it is snowing, semicolon. It is not snowing, semicolon. Therefore, it is raining, full stop. Now, this is a form of argument. Okay, so the first thing I want you to identify is that how many statements are in this argument? Can somebody volunteer to tell us how many statements are here?
3.
There are 3. Thank you. Now, the second one, if x is equal to 2, then x is less than 5, semicolon. X is less than 5, semicolon. X is an even integer, semicolon. Therefore, x equal to 2, full stop. For this one, how many statements are here?
3.
It's more than 3.
4.
It's 4, yes. It's 4. Good. So it means that the first 3 will be premises, the last one will be conclusion. So what are you supposed to do? So here, I'm taking the first example. First thing we did last week was that when you are given the problem, can we identify the connective here? It is raining or it is snowing. It is not snowing, therefore it is raining. What are the connectives in this problem? What English phrases form the connectives here?
Or.
So or is a connective, so we highlight that. Is that all?
Not.
Not. So not two is a connective. So you identify these connectives and write them out. So or, which will be V, and then we also know that not is a connective. We are going to use a symbol. So we've taken those ones out. Now let's come to the propositions. So how do we identify the propositions? By removing the connectives, and then what follows will be a proposition. So what are the propositions here? If I remove or, then from the beginning of the sentence, before I get to or, is one proposition. So what is my first proposition? Any?
It is raining.
It is raining.
It is raining.
Okay, so that's supposed to be, it is raining. It is raining. Okay, now then if you remove or, the next statement that follows is the next proposition. So what is the second?
It is snowing.
Snowing. Okay. So if you continue reading, semicolon, there, it is not snowing. They are talking about Q, which is negated. Therefore, it is raining. They are talking about P. So it means that in this question, there are only two propositions. That will tell you that you are going to use 2 raised to the power 2. And that 2 raised to the power 2 will give us exactly what we want. Now, I don't want to draw the table here. It will mess up my thing, but we can draw 2 raised to the power 2. That will be 4 rows. And true, false, false, true, false, true, false. That we are able to join what we need to do. Now that we are done, remember that I said for every question, you identify the premise and then you identify the conclusion. The premises are the beginning of a statement till you see a full stop. So from here all the way up to this is one premise. So if I call it P1, can you tell me what is joining it is raining to it is snowing? What connective is between them?
Or.
Exactly. So that gives you P or Q. So that is premise 1. Okay, that's premise 1. Now premise 2, from here up to the next semicolon, is talking about snowing, which is Q. But what is the connective in front of Q?
Not.
Good. So my second premise is negation of Q. Now, we are hinted with the word therefore. That word tells us that what is coming must be my conclusion. So I am done with the premises. So therefore, the word therefore, the next statement that comes must be my conclusion. And my conclusion says it is raining, and raining is P. So at the P side, the conclusion side, you are going to write P here. So we have deconstructed the problem by placing them into their propositions, their correct premises, and finally their conclusion. Okay, so the first part of this morning and late morning and afternoon's lecture, we are trying to make sure that given a problem, you can take your time and identify the various propositions, connectives, premises, and then conclusion. Okay, so now let's go on and try the next one, this one. Well, this one, if x is equal to 2, then x less than 5, semicolon. X is less than 5, semicolon. X an even integer, semicolon. Therefore, x is equal to 2. So the same route. What is the connective here? If there are connectives or one connective, what word it shows us which connective is being used?
If then.
If and then. Okay, so if we highlight that and then take that out, we will be able to identify our propositions. So connectives here is actually implies, which is known as if and then. Okay, and the symbol for if and then is, you can either use this like this, or you can use the equal to sign with an arrow at the end. This symbols is accepted. So that's our connective. Now, that's the only connective in there. So now let's remove if then, and then identify the propositions in this problem. What is my first proposition after the word if?
X is equal to 2.
X is equal to 2. Thank you. So that's the first one, x equal to 2. Now, after the word then, what's the next proposition?
X
X
is
less than 5.
X is less than 5. Okay. Again, here, after X is less than 5, after the semicolon, we have one more proposition.
X is an even integer.
X is an even integer. Okay. So this helps us to identify 3 different statements. So 2 raised to the power 3 will give you 8, 4 false, 4 truths, 4 false, 2 truths, 2 false, and 1 true, 1 false, if we are drawing the truth table. Okay, now let's now identify our various premises. Premises are from the beginning of the statement till you see a semicolon or a full stop. So this problem, what's my first premise? What is joining X is equal to 2 to X less than 5?
Then.
If and then. So that should be P implying Q. So P if and then Qs. So that would be our first premise. Our next premise is just a single statement. X is less than 5. Okay? X is less than 5. And that is Q. So our premise 2 is simply one variable. Now, the next statement is X is an even integer. That is also one statement, one proposition that is referring to R. So my third premise is going to be R. Now, then we see the word therefore. So what is coming must be my conclusion. X is equal to 2, which is P. Okay, so basically these are the various states or the various portions of an argument. Okay, so now let's now take questions, possible questions that we can deal with. But I want to show you where these questions are coming from. So this is your next group question that will be on the LMS. I'm going to take just a few of them, maybe question 2, question 3, and possibly question 7. Okay, so the questions are asked in a form like this. Is the following argument valid? Then you start reading. Okay, so after
please, we can't see your screen.
Oh, sorry about that. I thought I did show. Is it showing now?
Yes, please.
Yes.
Okay. So this is a PDF file that you see on the LMS. I hope they are there. So this question 1, but we are going to start from question 2. And then we will look at question 3. Question 3, I may not draw the truth table. I will not go to the end, but I will help you to identify the premises and the conclusion. But we'll do question 7. Yeah. Think that by the time we are done with this one, I hope everybody will be able to handle this. So we are going to look at this question. If you read a lot, you will become a brilliant conversationalist. Okay? I've colored all these things. I don't know whether the highlight will go away fast. It won't. It's saved. It means I have to open another one. Then if you become a brilliant conversationalist, you will have many friends. Therefore, if you don't have many friends, you don't read a lot. Is this statement valid or not valid? Okay, so I want us to work on this one. So let me share the Excel document that we type. We can type these things in there. So that is the question. But please remember what I said. Arguments are statements which are made up of premises and conclusion. Step 1, identify the connectives. Step 2, identify the propositions. And then step 3, you draw the truth table of the propositions, the compound propositions, the premise, and the conclusion. Then when you are done, you are going to identify the rules where your premises are all true, and then compare it to the conclusion. Secondly, the premises in a problem are the beginning of a sentence till you see a full stop or a semicolon. They can be single propositions or they can be compound propositions. And we use the letter P subscript to denote the number of premises. For conclusion, they are always the last statement, and we normally use the word therefore sometimes. But some questions, they don't use therefore, they will use then. Or they won't even use therefore or then, but it's simply the last statement. So the last statement will always be your conclusion. And they can also be either single prepositions or they can be compound. And letter C is used to denote them. Okay, so let's now take this question and see if we can do justice to it. Now, if you read a lot, you become a brilliant conversationalist. If you become a brilliant conversationalist, you have many friends. Therefore, if you don't have many friends, you don't read a lot. Okay, so the first thing is, what are the connectives here? What words represent connectives here?
If then.
Okay, so here in this question, the word if was used, but you don't see the word then, okay? In the PowerPoint, remember that I told you that in the PowerPoint, I hope you can relate. If and then can be written in the form of, look at it. They can use if, P, then Q. You can see then in the statement. Or they can use if, P, but you will not see then. You rather see comma Q. So the example that I'm showing you in the Excel right now, this example, you see that they said if you read a lot, comma, you don't see then, but you see you will become a brilliant conversationalist. So this is the second example in the PowerPoint. Okay, so now if it's a connective and the symbol is implication, now there's one more connective. What connective is that?
Then.
Don't. Thank you. So don't, and don't is what connective? Let's be sure everybody is on the same page. What word? Not. Yes, not. Which means that you are dealing with negation. Okay. So all we need to do is take away this if and don't. Then you identify your proposition. If I remove if from here up to the comma, it's my first proposition. Okay. So my P is going to be, you read a lot. Exactly. You read a lot. Okay. Now, then after the comma, there's another statement which is different from the first. And that is,
become brilliant conversationalist.
You will become a brilliant conversationalist. You will become a brilliant conversationalist. Okay. Let me end it here. Now, then after that, when you come to the second line, brilliant conversationalist is repeated, but there's one more statement here.
Then you have many friends.
You have many friends. Yes, you will have many friends. Now, sometimes when I'm doing this question, immediately I read this, they tell you it's not true. But in logic, when you hear statements like this, you must take your time and use logical arguments to prove whether it's valid or not valid. In real life, people will say that, well, reading a lot doesn't help you make friends. But logically, we can prove otherwise. So now we know what our propositions are. We know what our connectives are. So the immediately you know that you have three propositions, then immediately draw your truth table. So I have done them. PQR, 2 raised to the power 3 gives you 8. So 4 truths, 4 false. Then Q will be 2 truths, 2 false, 2 truths, 2 false. And then R will be a true, false, a true, false, a true, false. By the way, if you were not here last week, this thing will look like Chinese movie to you. I beg you, if you haven't, we were not here last week, please go over the video that we did last week, and that will help. Okay. Okay, so help yourself with those videos so that you can be able to understand how we draw the truth table. It's very basic in drawing them. Now then, let's look at the statements in the question and identify our premises. Remember, our premises are the beginning of a statement, so you see a full stop. So premise 1 should be from here out to this full stop. If you read a lot, you become a brilliant conversationalist. Now, reading a lot is P, brilliant conversationalist is Q, and the connective we know we have identified as if. So our premise 1 in symbolic form will be P implying Q. P implying Q, because he said if you read a lot, that is P, you will become a brilliant conversationalist, implying Q. Okay, now who can help us with the second one? If you become a brilliant conversationalist, you have many friends. What is joining to what?
Q
Q
and if sign implies R.
implies what? R. Thank you.
R.
Good, good, good. Now, let's take the last one. The last one is therefore. They start with therefore. So it means that must be a conclusion. It means the premises we are done. Now, so the conclusion starts from if you don't have many friends. Now, we know that don't is negation. So having friends is R. So if you don't have many friends, that should be negation of R.
Negative
You
R.
don't read exactly. You don't read a lot. And reading a lot is P. So my conclusion should be negation of R implying negation of P. Negation of R implying negation of P. Okay, so now all we need to do is draw the truth table and check whether this statement will be valid or not. So let's fill up the table. I've already done the PQR. So all I need to do is P implying Q. P implying Q. And then the next one will be Q implying R. And then the last one we said should be not R implying not P. Now, so that should tell you that I need to create not R before I can do that, not R, and I need to create not P as well. Okay, so now let's look at the first one, this column. Implication, remember, we are joining these two columns. The rule is you must look for P to be true and then the Q to be false. So which of the rows do you have P being true and Q being false? Which row is that? Or which rows are that?
Row 3.
Row 3 and row 4. Okay, so these are the two rows. Okay, so the rest of the rows, definitely 1, 2 will be true. 5, 6, 7 is also going to be true. 7, 8. Now let's do the same for QR. Which rows do you have Q to be true and R to be false?
Row 2.
Row 2.
And then which other row?
Row 6.
Row 6.
6. Great. So the row 1 will be true, row 3 will be true, 4 true, 5 true, and 7 and 8 will be true. Now let's create negation of R. R is true, false, true, false. So that will be false, true, false, true, false, true, false, true. Okay, and then negation of P. P was 4 ones and then 4 zeros. So negation will be
4 zeros.
0, 0, 0, 0, 1, 1, 1, 1.
good. Now again, we are now joining these two using P implying Q. So we are looking for true here and then false there. Which row?
Row 2.
Row 2. And then row 4. Okay. So the rest, row 1 again will be true. 3 will be true. Then 5, 6, 7. Good. So now we are done with the table based on what we learned last week. Now, so remember what the rule says. Go back to the rules and read it. It says that you first of all will identify all the rules that all the premises are altogether true. We call that rule the critical rule. So let's come to P1, P2. And this is my P1 and P2, this column. Where do I have P1 true and P2 true? Which rows are those?
Row 1, rows.
So row 1, so
Row
here,
5.
P1 and P2, they are true in row 1. Which other row?
Row 5.
Row 5.
Row 6.
Which other row? Row 6.
7 and 8.
No, 6 is not true. 6
7
is
and
rather
8.
7 and 8. 7 and 8 rather.
7 and
So this is where all of them, all the P1 and P2 are all together true. Remember, they must be together. If they are not together true, then don't pick them up. Now, all then you need to do is you go to the conclusion, the last column, and pick each of the values you got in the P1 and MP2, premise 1 and premise 2. So take them one by one, okay? So you take row 1 and then go and check row 1 for the conclusion. This row 1. So when I pick row 1 like this, if you're answering this in an exam, you do exactly as I'm showing. So row 1, you ask yourself, is row 1 true? If it is true, then you go to the next one. Is row 5 true? So you see row 1, I've highlighted it in green. It's true. Row 5, I've highlighted it in green. It's also true. Then you go to row 7. Row 7, is row 7 true? Again, row 7 is also true. And then row 8 is also true. Now, if in doing this, one of the values happens to be false, then our statement will not be valid. Exactly. So right now that row 1 is true, row 5 is true, row 7 is true, row 8 is true for the conclusion, then we can safely say that if you don't read a lot, you don't have many friends. Sorry, if you don't have many friends, you don't read a lot, then that statement, according to truth table, is valid. So that's how beautiful this thing can be if your connectives, if first of all, your tables were captured correctly, and then your connectives were captured correctly. Okay. Now, before I go on, before I do the next example, I show you the next example, I want to show you last year's paper so that if you choose to do this in an exam, at least be rest assured that you can do it. This was, where is your paper? Okay, this was your paper. This was last year's paper, distance learning. Okay, so that was a question, session B, the question on valid argument is question 13. That is it. Look at it. It says that in the following argument, determine the validity or otherwise. And for this, I didn't give you a story problem. I went straight ahead and told you what P1 is, what P2 is, what P3 is, and what P4 is. This one, there are 4 premises and the conclusion. So for those who will try to do this, and it's 10 marks, it's quite a good way of earning marks. You must, first of all, know the connective and correctly draw the truth table. Okay, so in exam, whether you are doing distance learning or you are doing regular, I make sure that the questions at least have been deconstructed into the format of premises and conclusion. So I'm only testing you on one, the connectives and the drawing of the truth table. But for your assignments, like I said, practicing these things, you are going to do story problems plenty because this thing I'm showing you, it is really being used in computer science, information technology. A lot of applications are derived from this. And you will have to deal with some of these things remotely. So you must know how to handle them. Okay, so I promise to go through one more. But let's do the second question, question 3 in the group question. This one, I'm going to ask you to help me identify connectives, the premises, the propositions, and the premises and conclusion. That's all. As for drawing the truth table, I hope you can do that yourself. So let's pick it up from here. The question says that if the slowness is system-wide, this one I haven't colored anything, so you have to do it yourself. It is either a hardware problem or an operating system problem, OS problem. Full stop. If a new hardware has just been installed, comma, it is either a hardware problem or a configuration problem, full stop. The slowness is system-wide and a new hardware has just been installed, full stop. Therefore, it is a hardware problem, full stop. Is it valid or not valid? Okay, so like we did first, let's pick from the question, what are the connectives here? The words that represent connectives.
We have if.
You have if. So this one, you see that you have if, comma, then. For this one, there's if, comma, there is then, because there's if here, in front here, okay? And then there is also then as well somewhere here. Okay, and so wherever you see all these ones, you just identify them, highlight them. Okay, now what other connectives do we see here?
Or.
Okay, so we have or is somewhere here, hardware problem or OS problem. Yes, somebody also said and. And I think is it here? It should be somewhere here. Slow system wide and a new hardware has just been installed. Yes, you are right. And so again, that one too. Then you also highlight that. Okay, so I think we have highlighted all of them. By the way, either goes with all. I hope last week you remember. So
Yes.
even though we don't, either it's not a connective, because it goes with all, you can write it out. Then you can identify your propositions well. Okay, now that we've done that, so let's now identify the propositions. You remove the connectives. So if I remove if, just before then, I have the first proposition. So can you read them for me? What is the first proposition?
The slowness is
in system-wide.
So the slowness is system-wide. Okay, then after the then, we have, you pick it is.
It is either hardware problem or OS problem.
No,
you don't bring
hardware problem. You don't bring
hardware
it
problem.
Yeah.
It is a hardware problem.
Problem.
It is a hardware problem. Okay. Then you come and pick the test again and then join it to an OS. I hope you say it.
Okay.
So that the next one you pick, it is an OS problem.
Yeah.
Okay. Now let's go to the second line. You remove the word if. What is the next proposition?
New hardware has just been installed.
So new hardware had just been installed. Then after the comma, you again must remove it is either, and the hardware problem we have identified it, but after that, after the or, you will get one more proposition.
It is a configuration problem.
It is a configuration problem. It is a configuration problem. Now, that tells you that 2 raised to the power 5. That is why I said I won't even try to do it today. 2 raised to the power 5 is 32 rows. Now, if you get access to this Excel, I've already drawn the 32 rows. That's a lot of work. And again, you can just see that I would, under normal condition, not ask something like this in exams. It's not that it's not doable. It's just that it is time consuming. Number 2, one single row mistake. I mean, if you should, you should make a mistake in any of the rows here.
Affect everything.
It affects everything. It's like work done is 0. It's unfortunate that after such a hard work, your conclusion that should either be valid or not valid is only affected by one single truth value that you make mistakes with. So over the years, I've decided, let this thing be practice. So practice and submit your work. Exams, I will stick to 2 raised to the power 3 and most 2 raised to the power 4, 16 rows. So at least you know you're managing. The answer booklet even doesn't have 32 rows. It's made up of 20-something rows. So it's not even a presentable work in exam. Okay, so like I said, I only want us to identify the connectives, the propositions, and then the premises and the conclusion. Now, if you take your time and start counting the full stop, you see that I have this whole thing up to the end here is one premise. From here, it's another premise. From here, it's another premise. So the premises are 3 before the conclusion, therefore. Now, so who can help us? If you pick the first statement from here up to here, it is joining slowness, which is P, to hardware, which is Q, to operating system, which is R. Okay, so who can join the 3 statements for us? If the slowness is system-wide, then it's either a hardware problem or an OS problem. What is joining P to Q to R? We know it's PQR because we have identified them. But what is joining P to Q and what is joining Q to R? And some way, somehow, there must be brackets somewhere because you can't join 3 things at the same time.
Yes.
So can somebody help?
P to Q
Okay, P.
Conditional implies, and into brackets, Q or R is in the bracket.
Good, into bracket Q or R. Yes, that is very good. That is very good. It's very, very good. I mean, you should know by now that if you have P implying Q, if you look at the word, no, that's on the first line. If the slowness system wide, you see that there's a comma. There's a comma after the system wide. Then, so it means that the P should imply whatever should come on the right-hand side must be joined first to become one statement. You know, implication must be left-hand side and right-hand side. Look for true and look for false. So you must join Q to R so that it becomes one entity before you now come and do P implying Q or R. Okay, that is very good. Now let's pick the second statement. A new hardware has just been installed. New hardware is S. It's either a hardware problem is Q, configuration problem is T. So we are joining S, Q to T. So who can help us with that? Premise 2.
S
imply
into bracket Q
Q
disjunction T.
T. Good. Exactly. S implying into bracket Q or T. Exactly. Okay, now then the third and the last premise. The slowness is system-wide. That happens to be P. A new hardware has just been installed. That happens to be S. The connective is AND.
P conjunction.
P conjunction S. Exactly. P conjunction. And this is the symbol I use for conjunction S. Good. Then the last one says that conclusion, it is a hardware problem. And hardware problem is Q. Okay, so we have done all the hard work. The rest is now you filling the table up and then trying to find out what is valid. Okay, so partially we are done with this. I said I want to do one more, number 7. Number 7 question will help me to conclude today's lecture. And that has to do with solving these problems without drawing a truth table. Obviously, I will not request that you do that. I think last year, some of your colleagues now in second year surprised me. They took that lecture serious and some did that in the exams, but it's not a requirement. If you see the question I showed you, you are supposed to use the truth table. So if you understand what I'm about to do after this example, and you can use what we call logical rules to do it, I will be very, very, very appreciative of you. It means you've taken this to the next level. Okay. So there are 2 questions here, very similar. If it is Sunday, the university is closed, full stop. Okay, so that is one premise. Full stop means one premise. Then you have the next premise. It is Sunday, another premise. Then here you don't see therefore, but the word the university is closed is the last statement. So in this particular question, there are 3 statements. The first 2 are premises. Now look at it carefully. What is the connective or connectives in this problem? If it is Sunday, the university is closed. It is Sunday, the university is closed. What's the connective here?
If.
It's if, exactly. It is if. No 2 ways about that. That must be if. Okay, now we've taken care of that. So that we are going to use the symbol implies, implication. Now then, then we now want to remove if from here out to here is one proposition. And that must be, it is Sunday.
Universities.
It is Sunday, just it is Sunday. It is Sunday is one proposition. The university is closed is also another proposition.
Hey.
If you say it is Sunday, the university is closed, you have joined 2 statements.
Yes.
You get it. Like we said, you remember?
There's no comma there that will show that.
There's no comma. I don't know whether in the original
That's the
question,
conclusion. The conclusion.
Yes, I don't know whether in the original question there's a comma. Let's see. There's no comma. In the original question, there's no comma. But you should know by the lecture 1. You remember today is Monday. When you say it is Sunday, that statement can either be true or false. The university is closed can either be true or false. So you can't join it is Sunday, the university is closed. Based on what we learned last week. Propositions are statements that we can determine that they're either true or false. So it mustn't go. The comma not being there should not what is the word? Should not be a hindrance. But at the same time, it is practicing that you will make you realize questions can be written in this format. Okay, so it is Sunday. Then the second one, the university is closed. Now, so based on this, my first premise is from here up to here. So that is, if it is Sunday, the university is closed. So that gives me P implying Q.
Yeah.
P implying Q. And then the second statement is, it is Sunday. This one, the second statement says that it is Sunday, which is this phrase, okay? And that becomes P. And then the last one is, the university is closed, which is also becomes my conclusion. That gives you Q. That's a very simple question. True is the part 2 will give you 4. So this is my table. So all I need to do is join P to Q here, repeat P here, repeat conclusion here. So let's do that. P implying Q. P implying Q. And then I repeat P, then I repeat Q. Now P implying Q, remember we are looking for true here and then false there. And it's occurring in row 2. Okay? So that will be here. This is the only place that it to be false. Everything else will be true. Now, the second premise we said is P. So we are just going to repeat these truth values. 1, 1, 0, 0. And then the conclusion 2, we are saying it is Q. So repeat the Q statements. 1, 0, 1, 0. Okay. Now, remember the rule. How do we prove that this statement is valid? You pick P1 and join it to P2 and find out the row or rows where they are together true. Now, if you take your time and look at this statement, the row that P1 and P2 are together true, that's what I've highlighted as yellow. That is only row. When you go to row 2, they are not together true. Row 3, they are not together true. Row 4, they are not together true. So it's only row 1. So here, it's only row 1 that they are all together true. Okay? Then you come and check the conclusion. Is row 1 for conclusion true? Again, when you come to conclusion, row 1 is also true. Okay? So this is my conclusion. It means that this statement, this one, we only have one row to check. This statement is valid. Angela, you have your hand up. What's your question?
Oh, sir. Hello, sir.
Yes,
so
please.
I want to say that, so can we say the question 1 follows the modus ponens rule?
Hey, Angela, that is where I'm going. I need you as my TA. Thank you very much. That's modus ponens. And those who don't know what she's talking about, I will finish with that. I'm going to explain. That's why I'm actually solving this question. It is a structure of argument. And that structure, when you conform to it, you don't even need to draw a truth table. Okay? But I'm drawing a truth table to make you see that because it is valid. And then I show you that this structure, P implying Q, premise 1, P, premise 2, conclusion Q. If you have an argument that conforms to this, then that argument is actually valid. It's actually known as modus ponens. Angela, thank you for already saving me when I get there so that I don't get too many surprises. Okay, but let's do the second part because still with what Angela said, you will see why that statement will not be valid. Again, we are going to compare it to one of those standard arguments. So let's look at it. Somebody typed, I can't hear you. I'm sure at the time, I muted my mic a few minutes because I had a call. I had a family emergency, so I had to respond. Sorry about that. Okay, let's take the second part. The second one says that if it is Sunday, the B part, the university is closed. It's similar to the first one. If it is Sunday, the university is closed. Okay? So this one, it has the same premise 1. But in this particular question, the premise 2 rather became the university is closed, which is Q. And then the conclusion rather became it is Sunday, which is P. So we are virtually going to repeat this same truth table. The only difference is that when I come to P2, I'll swap it with Q. My P2 is going to be Q, and then my conclusion is going to be P. Exactly. So let's check whether that statement will be valid or not valid. And that will be placed here. So I'm saying that P1 is P implying Q, just like the first one. This time, my second statement was rather Q, and then my conclusion was rather P. So let's repeat the P implying Q that we got up there. Now this time around, we are going to pick Q as my premise 2, and this will be as P. Now this was 1, 0, 1, 1. And then this Q, you know, is true, false, true, false. And then P, you know, is 1, 1.
True, false, false.
Exactly. Okay, so now let's take our time and look at our critical rule. Where do I have P1 and P2 together true. This time we are going to have two critical rows. That will be row one like this. Okay, I hope you can see it. This row one. Let me use another color. Is this okay? Okay, let me use the yellow. And then you can pick row 3. You see it? Yeah. Row 3, they are together true.
Yes.
Okay, so in your conclusion, you say that the critical rows are row 1 and then row 3. They are all together.
Okay.
Yes, together true. Now, you now come to the conclusion and then check for each one. You pick row 1 and check. Is row 1 for the conclusion true? And if you check, row 1 is true. Now go and check row 3. You see row 3, the conclusion is false. So when you write that row 3, the conclusion is not true, but false, then you will realize that this statement will not be valid.
Valid.
Okay? Will not be valid because the second row or the second critical row for the premises happens to be false for the conclusion. That is why these statements are not valid. Okay, so to sum up what we have just done, I'm going back to the PowerPoint. And like Angela just showed us, you will realize that at the end of the slide, I started referring to certain types of argument. There are so many of them, but just for the sake of learning, I've just listed, I think, about 5 or 6 of them. So if you haven't done your Socrative, when you start your Socrative, they will tell you if you have watched the video on modus ponens and modus tollens. I used to have that video on the LMS, but I don't think your class or your LMS has it. So when you see, have you watched that video, it's referring to, there was a time I will ask the students to go and watch the video because when I finished teaching, they still didn't understand. So I gave them a video to watch. So now, if you look at the last question we solved, you realize that this is exactly what we got. We got P implying Q. That was our premise 1. So basically, this is my P subscript 1. Now, then when you come to the second statement, my premise 2, P2 happens to be P. That's what we got. Okay, if you remember carefully, if it is Sunday, the university is closed. That is this one. And then we realize that it is Sunday was the second statement. Then my conclusion happens to be the university is closed. So it happens to be Q. Now, that is what Angela was telling us, that since the argument conformed to what we call modus ponens, P1 is P implying Q, P2 is P, and then conclusion is Q, any argument like that will always be valid. Okay? Will always be valid. So today I'm using it is Sunday, the university is closed. Tomorrow I'll say if today is Saturday, then I'll go to the mall. It also means P implying Q. So if I can structure that argument, if today is Saturday, then I'll go to the mall. Then my second premise will be today is Saturday. Then my conclusion is I'll go to the mall. That phrase or that combination of statements, if I draw the truth table, it conforms to modus ponens. Now, let's look at the second question we did. The first premise 1 happens to be, if it is Sunday, the university is closed. We got P implying Q. We got it right. That was correct, just like if P then Q. But the premise 2, if you remember correctly, my P2 was Q. If you remember correctly, my P2 was Q. And then my conclusion was rather P. My conclusion was rather P. Now, when we drew the truth table, we realized that our statement was not valid. Why? It was almost similar to modus tollens. Now, modus tollens, if your premise 1 is P implying Q, if it is Sunday, the investor is closed, and rather we had said that it is the university is not closed. If our second statement had been the university is not closed, and then your conclusion will be it is not Sunday. If that is a truth table we had drawn, the statement would have been valid because it would have conformed to modus tollens. Okay. Today we solved 3 questions in the Excel. 2 of them were valid. If you read a lot to become a brilliant conversationalist, I'm going to show you that one too here. But the last two, one was valid, which was this one, and the second one was similar to modus tollens, but they didn't negate the second premise and they didn't negate the conclusion. That was why it was not valid. Now let's look at the first example. If you read a lot, you become a brilliant conversationalist. That is called hypothetical syllogism. If you remember, our first premise one, P1, was P implying Q. Remember, that was P implying Q, like this. Now, our second statement was P2 was Q implying R. So we got those two right, Q implying R. Now, rather, our last statement was, our conclusion here was not R. I hope you remember. It was not R implying not P. Now, we got the statement to be valid, and I'm going to prove to you why it is valid. Last week, I gave you some few assignments. I told you to what we call local equivalent. Local equivalent are statements that they are English build-up, or the English that is used to write them are different. But when you draw the truth table, they are the same. So I will want to just show you why this hypothetical syllogism, P implying Q is your P1, Q implying R is your P2, and then the conclusion is P implying R. Okay? Now, if we go back into the slide and then we look at the beginning of if and then, I drew a table that looks like a cross, this one. Now look at this carefully. What does this symbol mean? I'm saying that if you draw a truth table and then on the left-hand side, you have P implying Q. And in this question, they are using, if a student is a female, then that student has brown hair. That is P implying Q. Now, if you come to the diagonal comparison, which becomes contrapositive, they will rather would take the conclusion and negate it. So negative Q will imply negative P. Now, how do we read that? If a student does not have a brown hair, then they are not female, or that student is not a female. So what this line means, this line that seems to be joining implication to contrapositive, is logically equivalent. Logically equivalent. My point is that if you draw the truth table for P implying Q and draw the truth table for not Q implying not P, the truth values will be the same. Okay? And it's actually shown, I don't know whether I showed it here. Yes, do you see it? This is P implying Q. True, false, true, true. Look at contrapositive. True, false, true, true. So you see that conditional, which is implication, implies, is logically the same as contrapositive. The same way, if you are giving Q implying P, true, true, false, true, is logically equivalent to inverse, true, true, false, true. Why am I showing you this? Because the question that we solved, the question that we solved, the first example, if you read a lot, you become a brilliant conversationalist. That was P implying Q. And then if you become a brilliant conversationalist, you will have many friends. That is Q implying R. Now, if we have said, if you read a lot, then you will have many friends. That would have been P implying R. But I am telling you that the P implying R, it is the contrapositive. When you find a contrapositive of P implying R, look at it carefully. Contrapositive of P implying R, will it not be not R implying not P? Are you seeing what I'm showing you?
Yes.
The P implying R on the left is logically equivalent to not R implying not P. So the question we got, the first example that we solved, is also hypothetical syllogism because it conforms to P implying Q, Q implying R, and instead of saying P implying R, we said not R implying not P, which is the contrapositive of P implying R. So that statement too was valid. Okay, so basically my point in wrapping up is that if you are capable of drawing the truth table, then I'm saying that kudos to you. And you can use a truth table to prove your arguments very well. That is very good. But I'm also saying that some arguments, when they conform to these standards, I've only mentioned modus ponens, modus tollens, and hypothetical syllogism. You can see from here that there's something called disjunctive addition. There's one premise, and then the conclusion is this. Conjunctive simplification. There's one premise, and then the conclusion is that. Disjunctive syllogism. One premise, and the conclusion is, two premises and one conclusion. Okay, so problems that are like that, if you can use the laws, then there's no need for a truth table. And at the end of my slide, not the one on the LMS, I try to prove a question like that. So he says, show that minus negative P or into bracket negative P and Q is logically equivalent to this. And I didn't use the truth table, I used the laws. The first one is called De Morgan. The next one is called double negation. The third one is called distributive law, commutativity law, disjunction, and identity. Now, these laws, I have highlighted them in the table here. But just that I don't want to burden students with learning all these rules and these laws for them before they can solve the problem that you can use the truth table to do. I only add this as a bonus. Okay, so today, this is the whole lesson on logical equivalence and at the same time, valid arguments. All you need to know are the use of the connectives and the drawing of the truth table. And basically enough, you can prove that a statement is valid. Okay, so I'm done. Any questions, any contribution, any comments from this? Okay. No question. Okay, so basically this is what I have for you today. If you are able to solve as many questions as possible, I hope that will take you through the rest of the problems that I've showed you. Looking at your course outline and what you are supposed to do, we are on track, and I hope that the next thing that we'll do will help us to solve the things that we are supposed to deal with. I'm trying to pick your course outline so that I will tell you what we should expect hopefully next week. Where is it? So 2026 distance learning. So based on what
sir, the 12B is what? Draw something.
12B. Oh,
yes.
Was it a past question or assuming? I don't know where I was and you saw that. 12B.
Sir, please, he's talking about the past question.
Your past question. This one. Sorry, where is it? Here. Was it this question or another question?
Question 12B.
12B.
No,
You mean
not
this one?
Not this
It wasn't.
one.
No.
It was, then that would be the regular class. See whether, is it this one? You mean, was it this one?
Yes, please. Is that draw?
No, the Hasse diagram. It's under sets. When we do sets, that's why I'm trying to show you what you should expect in the next course outline. When we do set theory, you can be able to handle that. I just opened the course outline. I think I have to open again. So this is a course outline. So we are going through the propositional logic, gone through the connective, we've gone through logical equivalence, we've gone to predicate. Have we done predicate? I'm not sure whether I've done predicate. So that I think I need to do next. Then we've gone through what is a tautology, contradiction. Today is valid arguments. Okay. So the next thing should have been set theory. But if I haven't done predicate, maybe next week I'll pick one or two questions on predicate statements. It's very simple. You see this picture that you are seeing is actually a predicate statement. That says that all cats are tails. Is it true that all cats have tails? And you tell me that it is true. But when you go on the net, there's a cat called Max. It doesn't have a tail. It's called a predicate statement. We use it to prove very, very simple methods of proof. So I don't have to teach it as a whole lesson. I just have to solve one or two problems to explain a predicate logic statement that involves a variable. And is a statement true or is a statement false? So our next big thing would be the set theory. So set theory, the question you saw has to do with properties of sets, where you can use sets to be able to draw Hasse diagram. We call it scheduling. So two member set, three member set, Cartesian product, and then from Cartesian product, the set applications is the question you solve on Hasse diagram. What is it? Okay, so draw a Hasse diagram. You are giving a set, and then when you draw it, it will give you a format of how to schedule or how to schedule items, depending on where you start from and where you go to. Okay, so basically, by the time you are done with set theory and Boolean algebra, you can take the whole question on question 12 and do it. Okay, so those things are there, and there are some questions on the elements. My recommendation is try and solve as many questions as possible after we are done with the topic. Download the questions and pick the topics underneath them and then solve them, because the more you do, the more conversant you become. I think that is it. So this is logic. This is chapter on logic. And then I have the Excel explanation sheet that I used today. That is what you find here. These are the various videos. So the lecture videos on the connectives and on the positional logic and valid arguments. You can find them here. And then you have the group assignments. There are some worksheets you can practice. So on logic, there's quite a lot of things you can do. I've given you the Socrates. So this one is hidden. So the next one is the method of proof. So I need to show you what we call predicate logic. That should be the next thing. Then after that, we go to set theory, which will bring us the Hasse diagram. So take your time. What I wanted to show you was where the questions are. Where do we have the past questions? They are here. I need to. So when you come here, you have the past questions here. I have 2014 to 2018 past questions. It's in PDF. Some of these questions have the marking scheme. And then you have 2023 and then 2025, last year's paper. So you have a lot of resources that you can practice some of the things we've done so far. Okay, so thanks for coming this morning and early afternoon. I hope, if not all of you, everybody understood this, especially if you were here last week. If you weren't here, then my recommendation, please just watch the first video and this will become clearer for you. Gradually, we are going to sort ourselves out. I wish you all the best over the weekend. Okay.
Yeah,
so
please.
take care. Yes, please.
We didn't have the rooming name for this lecture.
Okay, I think Linda will share with you. Actually, it was on the first slide I showed. This one. It's actually BIT weekend, Jan 2026, valid ARG, ARG, then DL. Okay, I can put it in the chat room for you.
Okay, sir. Okay, sir. Thank you.
Okay.
I'm sure it's not activated yet. I tried checking. I said we are waiting for lecture to activate it.
Yes. Yes.
What?
He said the lecturer has not activated it yet.
Are you sure?
Yes, sir.
Okay. You try the room name. It hasn't been activated.
Yes, sir.
That's what he said.
Oh, really? Let's see. Because I pulled it from the elements. Let's see whether what you're saying might be true. Maybe when I change the room name, I failed to activate it. Oh, you are right. Oh, yeah, that's it. I changed the room name and I failed to activate lunch. Okay, it's good. It's good.
Something like good afternoon. Oh, yeah, in class. I don't.
Where is my valid argument? You can valid argument. Okay. Okay, so now it's running now. It should you can now access it with the
All right.
rooming.
Thank you,
Thank
sir.
you. You're
Thank
welcome.
you, sir.
Okay. So enjoy your weekend. Next week we'll continue. God bless you. Bye.
Bye, sir.